Hello explorers and welcome to another video. Today we are going to do day 10 of the Advent of Code. And the Advent of Code 25th has already long gone, so we are no longer in the running of being the quickest to do this, but I will try to do all the remaining challenges as well. And day 10 is actually where we figure out where the best place would be to have a monitoring station to see all the asteroids in the system. And this is a line of sight problem. So if we have this example down here, the best place would be here to have a monitoring station because it can see 8 other asteroids. And if you can see or not is depending on if there is an asteroid in the way, if you use a line function to that place. And I found this line algorithm called Bresenheim's line algorithm, and I'll try to use that in order to figure out which asteroids can see which asteroids, and do some coding and see what I can actually do, and if it's a good one, yeah, we'll see. I've not done that much drawing, or I had some course in university where we would do a paint tool from scratch, and that course was tedious and something that I didn't really enjoy, but I think these kinds of puzzles are at least interesting, and I surely think I will learn something from this. So I'll start some coding and I'll be back when I've done so. And we're back, and I tried a lot of different algorithms that I found online, and this was a little bit of a challenging one. The result I got, so this was how many different asteroids could you be seeing from a specific point in this cluster, what is the best position to put your observation station, and how many asteroids could you see from that location. I got 247, so let's see if that is the correct answer. It is! You get a gold star, I get a gold star, everybody gets a gold star. So, to the code. This was a lot. So let's start off with just look at at some of the code. I have this input here, so this is the input txt, and I need to figure out how it's actually shaped. In this case, it's 26 times 26, and then I read it in line by line and just create a grid where I have -1, where I have an asteroid, and I haven't actually determined how many is at that position, and then I put 0 where there are no asteroids. So I know that where I have -1, I want to calculate something, and then I go through the whole grid and look if I can see any asteroids. Great! So I will put into that map position how many asteroids I can see at that position. This function, how many asteroids I see, it looks at the current position and then goes through whole of that net of asteroids and skip the current one that we are looking at and see if it, first off, the position that it wants to draw a direct line to is a position which is not 0, so it's not an empty spot. And then I can see if I have an accepted line to that spot. And if so, I will add to the seen asteroids, and then I will return that when I have looked at all the points all around. So that was a pretty simple thing to follow, I guess. Now we have a little bit of a problem here, because how to figure out if one point is on a line between 2 points. There were so many different solutions to this, and some of them were good, some of them not so good. First off, we have the line here, so we go from AX to BX, or AY to BY, and we have our little map. I will create a new point, C, CY, CX, and I will go through all the positions here, so I will try all of them. If they are not equal to any of the points on the line, if they are equal to any of the points of the line, I will just continue to skip that point. I will check if it is asteroid, so I need to actually keep this one in mind. Then I calculate the area between A, B, and C. So the actual area of that triangle. And if that triangle area is 0, then I know that they are on a line. The problem is that if C is a continuation of that line, it will still be on that line. So if BX is between AX and CX, or A is between C is between A and B, that's fine. But if B is in between A and C, that is a case that I don't really care about. So I added these calculations down here, and these are actually just looking how long is the distance between A and B, how long is the distance between A and C, how long is the distance between B and C. And I want this distance between A and B to be larger or equal to the distance between A and C and A, B and C. So I want that distance between the points that I'm interested in to see that this is on that actual line. I want that to be a larger distance, and I also want the area to be correct. In that case, I know that C is somewhere on the line between A and B. So this took me a long while to actually figure out, but I believe that this is correct, and we got the right solution. So I'm very satisfied with that, as I'm not really the guy to draw vectors and figure those things out. So let's see what the second entails. I will read this and get back to you when I know what I need to know. And I'm back, and this was one of those, oh my. So now I need to figure out, if they have a laser at that position where we start, how long will it take for that laser to, or which will be the 200th asteroid to be destroyed if that laser vaporizes asteroids in the vicinity. And it starts from right up and then rotates 360 degrees. So I need to figure out how to do that. I guess that you need to do it with angles or something. Yeah. So this will be an interesting one. So which is the 200th asteroid to be vaporized? That is what I need to figure out. So I'll do some coding and I'll get back to you when I figure this one out. And I'm back, and this one got me a little bit stumped because I believe I have the right solution, but it doesn't really work well with the examples you have here, because it says that in the large example above, the best monitoring station is at location 11 times 13, or 11 x 11 y13. Fine. Then it should vaporize the first at 11:12 and then at 12:1. So that's the second asteroid to be vaporized. But 12x12 y1. So I took this example 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This position does not have an asteroid, so it doesn't work. So this is the next one to be vaporized, 2, 2. And my example is actually, when I run it, showing that specific sequence. So asteroid 2 to be vaporized is 12y2. So I'm wondering if they have written something wrong here, or if their function is flawed in any way, because it doesn't make any sense for me. But as it's getting quite late here, I will try my solution to the problem on the large example and see if that is the correct solution. If not, well, no harm done. We have tried it out and seen if that is the correct solution. Otherwise, I need to think about this a bit more. So we should take x multiplied by 100 and then y. And in my case, it's been 914 then. So let's try that. 914 and submit. No, my answer was too high. So I have something wrong in my calculation here, and I'm not really sure what's going on. It's very strange. Oh, wait a minute. I didn't reset the positions. I saved those somewhere here. Let's see. It was 1914. So those were the best solution for the large example. 1914. So let's put those in as my point. 1914. So that's the position here. 1914. So let's run it again. So this is with my large example, the right input point, and then number 200 should be 1211. So that's even higher. 1211. Let's try that. You're too high. So that was not the correct solution. The elves are placing bets on which 200th asteroid to be vaporized. And my 200 asteroid is 1211. I can just move 2 points down and see 608. That's a really bad guess. Yeah, I need to wait 23 seconds to answer that one. But it's really strange to me that this routine that I figured out is not the right answer. It's too high. Yeah. So, yeah, I'm not really sure what's going on here. I have the right puzzle input. Yeah, I need to figure this one out. It's a bit strange because I'll show you my little work here, and maybe you can find something that is incorrect in my solution, and we can help each other out. So all these accepted and things is not used at the moment. So what I do here is that I first off read the actual input, and then I go through here. Do I actually see if the point... No, I don't. Now this is the one of the problems. map cy times max x plus cx. Strange that I got something wrong. If this is equal to 0, then we continue, because those are not interesting. I got different result here, right? Yes. So let's go back and try with the large example here. But I still think this is a really strange example, because it doesn't work well at all. Let's see here, let's copy these out. And these were 11 and 13, I believe. Yeah. So let's see if we get better results now. And no, this is so much more wrong. Oh, Jesus. That at least it is a different result, and the 200th is also totally wrong. So I'm not sure what's going on here. I read the map position. Yeah. So what I do here is that I go through my map and I check if the current position is an incorrect one. I check if the current position by the map coordinates is 0. Then I continue as well, because that is a position that I don't want to actually look at. And the reason that I add 1 here is that the map actually starts at 1, 1, I believe, in the top left. No, it doesn't. Corner is 0, 0. Yep, then we remove these again. Let's start over then. Do I get the right coordinates now? No, we are totally off again. We have the right shape, but still not the correct answer. Yeah. So what I do is go through these. I check if the current position is 0, then it's not an asteroid, so I don't care about it. Then I create a point, and I get the angle for that point. And the angle is just calculated like this, degrees, and then the tangent of the line. And then I check that it's in the bounds of 360, and then I figured out that I want to look up, and in this coordinate system it's actually 270 that is looking up. So what I need to do is flip the whole thing around a bit by 270, and then I will get the angle of the asteroids. So the first asteroid it will find is at 1112, because the other one was 1113, so the one above is 1112. And then I will, when I have the angles, I create a map with all the angles and the points. So if there isn't in this map isn't an angle specified, I will create a new list of points in that angle. and then I will add this specific point to that list. So I will get a list of all the angles and the points that are linked to that angle. Then I take this base point that we have and I go through the list, or the lists, and I will sort those by distance to the base. So I get the smallest numbers closest to the actual point, and then I will go through and list the asteroids. I will take the angle at 0, so this would be up 90 degrees at the moment, and I take that position and then look for the specific value there. Is it going in the wrong direction, perhaps? Yeah, we'll see. So if it is, then I will look at this specific angle, and if the size of the angle is larger than 0, I will output this specific asteroid, its number and a specific point, and then I will remove it from the list and increase the number of asteroids outputted. So this is the little function that I figured out. I might have gotten the angle function incorrect. So let's do some debugging here. We do all this, and then set the breakpoint here and see what the angle map actually entails. We see here that we get these 12 here, those are straight up, and then we get integers with large numbers here, so we don't get them in order. So that's the problem. Yeah, so now I actually get the correct values, but at the incorrect order of the hash map. Oh, that's so annoying. Oh my. Key set. Let's see, can we sort this? I get a set. Okay. Let's create a list of this set, list of integers, new keys, new array list. Can I just put the set in there, and then keys, sort, integer, compare to, yeah, and then keys. Perhaps that will work. Let's see here. Now I get the oh, so annoying. I thought I got the right one. Let's see here. 5 degrees, and in this list I have 12, 1. So why didn't I get that first? Let's see here. We have sorted those. No, we haven't sorted them. So I guess that this is because the angle map is not accurate enough with int. So let's try float and see if those differ in any way. Float. 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 And don't do any math around here. So we just get the angle. Let's see what we get then. Yeah, now I actually get the right results here. Let's see down here at 200. 200 is actually the right result as well. This is exciting. So you actually got you got to see what I debugged this one. So maybe we can solve this today if we are a bit lucky with this. So at 200 we have 712. So let's try that. 712. Submit. No. So 712 was not correct. No, Jesus. We forgot to change the values again. It looked so promising that I just wanted to run it. And 305, yes. Yeah, so I need to wait 4 minutes and 10 seconds until I can try again. But this one looks promising. So, to recap, what did we do? We did a lot of fixing now. First off, we read it in. Then I set the actual base coordinates to 1914, which is the base coordinates for the best result in the example where in the old map. So when we looked at for the position where the best result was, it was at position x19, y14. Then we go through each position in the array. We see that we don't have the specific position that we are standing on at the moment, and we also check that there is an actual asteroid at that position. We look at that specific point. We get the angle for that point in floating variable, and after we get that angle, we see that if it's 0, and then we will just add 360 to it, but then we will actually start from the baseline, and that's not correct. We want to actually start from 90 degrees, so we subtract 270, so we will go back in the loop to 90 degrees, and then we will add 360 again if it's below 0, so we will actually get a new point of reference where up is 0 degrees, and then we will go around, and that is the angle that we will get back. Then we will check if this specific angle as a floating point is contained in the map that we set up. I have set up a map of points, a list of points with float, and if we don't have any references yet, we will add a list of points to that angle. We will get that angle and add the specific point to that list. So now we have a list, a specific angled list of points, and we will go through each of these lists and sort them by distance from the base point. Then we will set the number of asteroids to 1, so we start at 1, and we will count until we have seen 200 asteroids. And here I needed to go and take the actual keys of the map and sort those keys. So I actually start at 0, then 5, 7, or 6, or whatever the amount above 0 would be. Otherwise, we will actually go through the keys in the wrong order. Then I will go through each keys in turn and check if that key has any values on that angle yet or still. If it has, I will print that specific angle out or that specific point out, remove that point from that list, and then increase the number of asteroids that I've printed out. And then we'll go through again, and the next time I get into this for loop, the angle map can actually be 0, so I will just skip that one and check different other angles in the rotation around. So it can go through a number of rounds here. So that's the approach that I went with, and at 200 we got the results x3, y5. So that's 305. So x multiplied by 100 is 300, and then 5 is the y value. So we add that, and it's correct. You get a gold star, I get a gold star, everybody gets a gold star. So we actually solved this one. It was a hard one to do, and I did so much wrong in the solution, but we went through, we figured out everything that I did wrong, and we actually got to the right solution. So I learned a lot today. I hope you learned something today. If you liked this video, give it a like, share it with your friends and colleagues. If you have any comments, suggestions, leave them down in the comment section down below. If you haven't subscribed yet, like puzzle solving or interesting new libraries or other Java news, then please subscribe to this channel, and I really hope to see you in the next video.